Welcome,
Awesome.
everyone. We are so happy that
Welcome.
you are joining us tonight on a Tuesday night after probably a very long day of school and work.
Hi, everyone. Thanks for coming.
Welcome, welcome. Awesome.
We'll give people some time to roll in, especially at 7 p.m., finishing dinner and getting all of that stuff squared away. Take some time, and I'm really appreciative of everyone being here.
We are so happy that you are here.
What a great turnout.
I know, no kidding. Love to see it. Awesome.
Yeah. Maybe we can test, would someone mind putting a question in the Q&A, like maybe ask what my favorite color, orthographic pattern, or winery, or baseball team is, just so that we can make sure that that's all good to go and that I get to answer your question. Oh, favorite word. Okay. All right. Yes, this is great. Perfect. Thanks to those two who did some questions. Favorite word. I played a really fun game with undergraduate students who I'm teaching this quarter in a new cross-disciplinary seminar. And I had them down in our anechoic chamber in the basement of our building in Northwestern, which is a room that has about 3-foot thick foam on all sides, walls and ceilings, to reduce any reverberation. And somebody said, syncope, as our like a practice for, we were talking about how sound and how different sounds and meaning travel, and I was like, that's a great word. So so that favorite color is going to be navy blue. As a New Englander Red Sox fan, this like coloring, I wear a lot of navy blue. Red Sox fan, baseball team. Favorite book, ooh, I love this pretty modern novel called The Liar's Dictionary that is intersecting stories about a young woman in modern times and a guy in olden times she is deciphering fake words that he inserted into a dictionary, and he is telling his stories about that. So and are we ready for the end of the year? Yes. Favorite vacation, Napa Valley. And now that we have that all squared away, and our questions work, so please feel free to put questions in that are clarifying questions as we go. And you can give me a little, chat, since I'll be sharing my screen. I won't be seeing them as easily, and I can answer them as we go. And then my favorite part of this is being able to talk with everyone and answer your questions at the end. So I'm going to prevail to my natural tendencies and talk fast so that we've got lots of time at the end for questions. So how about if we get started?
Perfect. Awesome. So
Great.
thank you everyone so much for being here. We are so happy that you are here, especially on a Tuesday evening in May. Crazy, crazy time. So thank you so much. So my name is Kellen Cyrock, and I am a board member for the Reading League Illinois. We've got a really exciting evening planned for you, and I know that you all are very excited to dive in. So we're going to do a quick overview of some nuts and bolts for tonight, give you a few updates about what's going on with the Reading League Illinois, and then hand things over to Dr. Norton. So tonight we are using the webinar format, which means that your audio and video are disabled, but you can still put questions and comments in the chat, which will be seen by everyone. Or you can use the Q&A, which will just be seen by the speaker. Please feel free to type questions in either place, and we'll monitor those and do our best to get as many of those as possible during the Q&A. There is a link to tonight's handouts for tonight's presentation. I'll put that in the chat briefly, and we will be sending out a recording of this event to everyone who registered as well within at least 48 hours. Finally, if you are interested in getting a certificate of attendance for CEUs or Illinois PD hours through ISB, then we will post a link to register for those at the end of the webinar. Couple more things. We have a very exciting summer planned for all of you members, Reading League members. We have a summer lunch and learn series. So we are going to spend 5 weeks digging into different research articles focused on the comprehension strands of the reading rope, including vocabulary, background knowledge, comprehension strategies, and more. Back in the spring, you may have seen a series of 4 blog posts focused on bringing knowledge building into classrooms. They made the rounds on social media, but were originally published on ASCD and written by the Scientific Advisory Committee of the Knowledge Matters campaign. After those posts were published, the committee was asked to identify a collection of freely accessible articles that summarize different aspects of their research. And the articles we'll be diving into this summer are all taken from that collection. So not only are they carefully curated by some of the most well-respected researchers in the field, they are all free and open access. I always like to say that open access is my love language. So we'll be meeting virtually during the noon hour on selected Wednesdays in June and July for informal conversation, collaborative thinking about these articles, and just some networking too. So we hope that you will join us. You can come to as many or as few as you would like, and attendance certificates for CEUs and PD hours will be available for each session that you attend. We haven't quite set up registration for the series yet, but we are going to limit this series to members only. So the next slide, I will tell you about that. So very exciting times. We just started our membership drive. So the Reading League Illinois is the 19th state chapter of the Reading League, which is a national education nonprofit led by educators and reading experts dedicated to promoting knowledge and accelerating the global movement toward reading instruction rooted in science. As a state chapter, our all-volunteer board is currently made up of 9 folks from all around the state who are passionate about improving literacy instruction in Illinois. We come to this work from a variety of perspectives: teachers, parents, university professors, instructional leaders, curriculum coaches, dyslexia specialists, you name it, but we all share a commitment to working towards literacy and justice for all. So we just launched our membership drive this past weekend, and I would love to invite everyone to become a member. It is only $25 to join, and benefits include our monthly coffee chat series, our summer lunch and learn series, like I just described, and advanced access to registration for free webinars throughout the year. For a little bit more money, you can also receive Illinois PD hours for each event that you attend. We do rely on membership dues to fund all of these great events, so please do not hesitate to join us and or make a donation using the QR code on your screen or the link that I will drop in the chat momentarily. If you've already become a member anytime in the last year, you'll need to renew your membership now to maintain your membership privileges. As a special perk, everyone who joins or renews this week will be entered into a drawing to win a $50 gift card to the Reading League shop, which has a ton of really amazing resources, professional resources, and fun swag like t-shirts and mugs. I want to extend a special invitation to any pre-service teachers who are interested in joining us too. Membership for you is absolutely free. So please don't hesitate to become a member if you are a pre-service teacher right now, even if money is a little tight. So all of that being said, let's dive in. It is my very great honor and pleasure to introduce our presenter tonight. Dr. Elizabeth Norton is an associate professor in the Department of Communication Sciences and Disorders and director of the Language Education and Reading Neuroscience LEARN Lab, both at Northwestern University right here in Illinois. Dr. Norton's research investigates the brain and behavioral basis of language and reading development and disorders, particularly early identification of disorders such as dyslexia, developmental language disorder, and autism. She uses EEG, ERP, and MRI brain imaging methodologies to investigate these questions in infants, toddlers, and children. Collaborations include studies of developmentally sensitive measures of premature infants' brain development, indicators of mental health and its relations with language, and intervention for cardiovascular health. Dr. Norton also serves as co-director of the Neurodevelopmental Resource Corps within the Northwestern Institute for Innovations in Developmental Sciences. Dr. Norton, we are so excited to learn from you tonight, and the floor is yours.
Thank you, everyone. I'm so excited to be here. Thank you to the Reading League for having me. Thank you all for being here. Let me share my screen. Classic Zoom kind of dialogue here. So Kellen, give me a heads up if anyone has any clarification questions as we go. Otherwise, let's get started. Let's use all of our time as efficiently as we can. And so I can leave lots of time to chat with you all at the end of the talk, which is my favorite part of all of this. So here is my info, email, lab website, Twitter until we can't Twitter anymore. Please use the Q&A feature in Zoom for any questions. And if you'd like to use these materials, the Reading League is going to share a PDF of my slides with you tonight. But please let me know if you need to use these in your other various outreach, teaching, things like that, just so that I can make sure that we're sharing all copyrighted things appropriately and so on. Disclosures, nothing relevant. I am giving my time to Reading League of Illinois because they're a great organization. And as you heard, you should support them and do all of the things that they want to do. I don't have any disclosures. I'm not selling anything. I don't make any curricula. I am not trying to tell you anything about, trying to sell you anything, trying to give you the best science that I possibly can share with you. So thank you to the Reading League for having me, and thank you all. It's 7:11 p.m. on a Tuesday, and I'm really grateful for you all taking the time to be here. So thank you. What we're going to talk about today is defining what characterizes a RAN, rapid automatized naming task, and how it differs from other tasks and measures that you may be familiar with. Next, we're going to describe the research evidence for why RAN is related to reading and an early predictor of reading, and summarize the theoretical basis for why this is so, that we see this relation between RAN and reading, and why RAN is hard to train. And then we'll also give some brain data, because I am not just a reading enthusiast, but also a neuroscientist, and excited to share with you what we know from brain science that can help us better clarify these behavioral relations between RAN and reading that we see. So a little bit about me in 4 pictures. Top left is the White Mountains of New Hampshire, where I grew up in a very rural area, and I've been back and forth, and I'm a little underslept. My mom is getting older and is needing some support, so I've been back and forth to what looks like this region in the last few days, and there with her. But I grew up in a really rural area, and from very early in my life, in my little tiny town of 3,000 people, I remember clearly being interested in first grade why I could read some books and other children in my class could not. And they had to read the books that had like big blue labels on the top or things like that. So I really remember clearly from the earliest stages of my development being interested in individual differences in reading. And fast forward up to the top right picture, many years later, after I had graduated college, I was a high school teacher at Landmark School in Pride's Crossing, Massachusetts, north of Boston. And this is a private school for students with language-based learning disabilities. So I taught high school biology and chemistry to students who were otherwise bright and motivated and wonderful, but reading was really difficult for them. And this was the view, if you really like craned your neck outside the window, where I was also a dorm parent for 19 high school girls. And this was the ocean there. And I learned so much there being a teacher. And when I left to go and pursue my PhD, I had to go and tell the head of the school, and I was really nervous to tell him that I was leaving. And I wanted to go back and do more research to try to identify students with language-based learning disabilities like dyslexia early. And I was petrified. I went and I told him this, and I got into a PhD program, and he said, "Miss Norton, go put us out of business." And that's what I have been respectfully trying to do now for the last almost 20 years. Fast forward to the bottom left picture of the view from the top of the hill of Tufts University, looking up to Boston, where I did my PhD working with Marianne Wolf and got my start in doing research on RAN. And after doing that and a postdoctoral fellowship at MIT, focused on cognitive neuroscience, I moved to the bottom right corner, which many of you may recognize as the view from the Northwestern campus in Evanston, looking to downtown Chicago. So I've now been a professor in the Department of Communication Sciences and Disorders at Northwestern for 8 years, and focusing on using brain and behavior measures to understand, as you heard earlier, a variety of language-based learning disabilities, but with my real heart and focus being on reading disabilities and dyslexia. Okay, let's dive in and talk about RAN, the reason why y'all are here today. So what is RAN? RAN, or rapid automatized naming, is succinctly defined as the ability to efficiently name aloud an array of repeated familiar items, such as objects, colors, letters, or digits. And I want to highlight a couple of aspects of this definition. So first, efficiently. Efficiency means having accuracy and speed. So in a RAN task, we assume that the participant is accurate already in naming these items because we really want to query their automaticity, or their speed, and essentially the degree to which they can do this task with as little conscious effort as possible. A second important part is aloud. We don't have a method yet to be able to accurately assess children's ability to name items when they are not naming them aloud. So we do add on this articulation component where we need them to name things out loud so that we can hear them and assess them. But we know from lots of existing research that it's not the time it takes us to say the name of an item, but actually the time that it takes a participant to pause in between the name of the item and recall the next item's label that matters for RAN and that correlates with reading. We do this in an array, so a grid essentially of items. And as I'll talk about, it's really different than naming individual items one-on-one. And that really differentiates RAN tasks from a number of other tasks. We do this with repeated items because we want to emphasize the automaticity and the speed component and not the accuracy component in a RAN task. And so that's why we use a limited familiar array of items. You know, we don't use all 26 letters, for example, or all infinite colors. We use just the ones, just a few that children can become really familiar with so that they can name them easily, and really we can focus on their automaticity and not their accuracy in their naming. And lastly, familiar items. So again, we could ask children to name all 26 letters or many different colors, but RAN is really about the automatic piece of this. And so we want the items that our participant is naming to be just at the tip of their tongue, easily accessible as possible, so that we can best assess what their access to that item's name is and not their ability to know what it is. One other distinction that's important that I want to point out is that the four major kind of characterized RAN tasks that we use are object, colors, letters, or digits. But we often make a distinction between letters and digits, which are alphanumeric, as we call them. And these type of stimuli have a stronger relation with reading than do naming of objects or colors. And we think that's for a couple of reasons. One is that letters and numbers are what we would call a closed set. I'm not going to make you learn a new letter in the English language that you've never seen before, or a new digit, whereas essentially there are somewhat infinite objects and colors that we could ask someone to name. You know, shades of blue, and, you know, a new object that you've never seen before that, you know, I don't know, a new type of cookie or pastry or something that hadn't been in your naming repertoire before could get introduced. And also letters and digits stand for things in a symbolic way that's really important, that mimics the reading process. And that is part of why we think that letter and digit naming is more strongly related with reading, because reading requires these same types of processes where we're requiring symbolic associations between meaningful things that we know in the world, like sounds, and abstract things like letters on a page. So if you've never seen what a RAN task looks like, it looks much like this. This is from the RAN-RAS tests, and this is a letter naming grid. So you'll see that there are 50 total items arranged in an array, letters across rows and columns, and we would ask the child to name the letters as quickly and accurately as they can, going across each row, top to bottom, left to right, in the same way that they would as they would read. And here you can see we use 5 different letters, D, S, A, P, and O. And we would ask the child to name these letters as fast and accurately as they can and record the total time it takes to have them read that or name that array. We take into account things like errors and self-corrections more in a quantitative way, because those also factor into the total time it takes a person to name these letters in the grid. And we can use those to know whether a child is relatively accurate or not, but we don't factor those in as something that factors into a standard score. So with that in mind, why do we care about this? Why are we here in this webinar today? RAN is what my advisor and colleague, Marianne Wolf, and I have referred to as a microcosm of the processes involved in reading. Essentially, so many of the things that we need to do to be fluent, comprehending, accurate, proficient readers, we need to do in RAN, but we remove many of the demands in RAN. And so it allows us to be an early predictor of reading ability and also a correlate of reading ability from the earliest stages. And this relationship between RAN and reading persists across the development of reading ability. There are like so many things in our field. Like I'm mostly going to talk about dyslexia, but you could just substitute the term specific learning disability in reading or reading impairment or things like that with getting the same general meaning. The synonyms for RAN include things like rapid serial naming, naming speed, and instead of rapid automatized naming, you might see rapid automatic naming. The things that are not the same that you should kind of know the difference between are discrete naming or confrontation naming. And I'll say a bit more about what those are. As we differentiate RAN from other tasks, it's important to know that RAN is more than just simple speed of processing. So if you're familiar with neuropsych or psychoeducational assessments like the WISC symbol search or coding that ask children to make associations between visual symbols and meaning are different from RAN, because RAN is this serial process with familiar items, and there's also this out loud naming component. So when we do studies and we consider simple speed of processing, or even something like if I flash a screen with a light and ask you to press a button as fast as you can, those type of measures that are just about how fast you can process information in general are not as good predictors of your reading ability as RAN is. There's something about, as we'll keep talking about, these ways that RAN works being the familiar items presented in an array that you need to name out loud in the serial fashion that make it really strongly related with reading. There are some excellent papers in the history of our field that talk about the different subcomponents of reading and talk about rapid naming as a subcomponent of phonological processing. So Joe Torgerson and Richard Wagner and others who are extremely influential and brilliant researchers in our field for a long time talked about an umbrella of phonological processing that included phonological or phonemic awareness and rapid naming. And I think it's a bit misleading to think of them as being part of the same construct, because the correlation among them is quite weak. It's around a correlation of R of 0.3. And there is a joke among researchers that the world is correlated at R of 0.3, like your like of ice cream and your height is correlated at R of 0.3. That's a silly example, but it's not a strong relation. There's a good differentiation between phonological and phonemic awareness tasks, phonological memory tasks, and rapid naming tasks, even though they all importantly relate to reading ability. And lastly, I mentioned confrontation naming or serial discrete naming. So if I just put one item at a time on a screen for you to name, that ability, the speed that you would name those items, is much less strongly related with reading concurrently and over time than the serial, and a grid RAN naming is. And that is likely because RAN is more like the reading process, where you need to move your eyes and kind of process multiple pieces of information at the same time. I have some research with colleagues at Northwestern showing that there are differences in RAN in individuals with Fragile X and autistic individuals who have no differences in reading, but it goes to sort of serial processing and things like that. So if you have questions, follow up, and I'm glad to share more on that research, but we're going to talk about mostly the RAN reading relation today. Another important kind of distinction or thing to know the difference between is a RAS task, or rapid alternating stimulus, rather than rapid automatized naming. And the difference here is that we would ask a participant to name multiple types of stimuli in the same grid. So as opposed to naming all colors like you see in the practice version on the left, the version on the right includes letters, digits, and colors. And so we know that this is related to things like your switching capacity. And I'm going to see that there's a question in the chat. Does the array size depend on the age and level of the student? Typically, no. For the studies and the standardized tests that include RAN, we usually have a grid of, for example, 40 to 50 items. And we have different norms based on the age and level of the child, based on their grade or age, but we don't typically give fewer items to a child who's younger, for example. A question that I'm asked a lot is, how does this relate to letter naming fluency? So a task like you might see here, or a standardized task, for example, from something like the DIPLs. And a big difference, if you look here between the RAN grid that we just looked at, is you can see that this letter naming fluency task has all of the letters of the alphabet. They're in different cases, upper and lower case, they're in different fonts. And so the big difference here is that RAN allows us to focus on the automaticity of retrieval rather than focusing on letter knowledge accuracy. And so for RAN, we don't even administer a RAN task, ideally, if the child is a RAN letters task, I should say, if a child is not already fluent and automatic in knowing their letter names. And so the distinction between letter naming fluency and RAN is that the research really shows that only RAN, which kind of restricts the set and really tries to tap the construct of automaticity, is the thing that has been shown across studies time and time and time and time and time and time again to really relate not only to concurrent literacy and pre-literacy abilities, but to actually predict children's future reading ability. We know that letter name knowledge, being able to name each of the letters in the alphabet, let's say in English that we're all talking about here, is a good predictor of reading ability for a short time when not all children know their letters accurately. And there are important sort of socioeconomic and structural advantages that come along with this, for which children got to go to high quality preschool and things like that. And so this is not the best measure of predicting children's later reading proficiency. So how and why is RAN related to reading? A little bit of history here that I'll move through quickly. RAN was never designed to be a test related to reading and literacy. So it was actually discovered and sort of created by a neurologist named Norman Geschwind in Boston, who had a stroke patient who could name colors accurately, but not quickly. This person needed a lot of time to be able to name each color. And so this distinction between accuracy and automaticity was kind of raised to his consciousness. And he worked with another neurologist named Martha Dankla, and she was really interested in learning disabilities and dyslexia. And so she applied Geschwind's RAN task to a group of 5 boys with dyslexia, and they all showed slow color naming compared to typically reading peers. She then teamed up with Rita Rudell, and they found that RAN differentiated poor readers from children with other learning disabilities like ADHD, and they were the first to associate RAN with automaticity. And after the first 50 years or so of RAN research, 20 years or so in, my PhD mentor, Marianne Wolf, and her colleague, Pat Bowers, proposed the double deficit hypothesis of dyslexia, which was that the deficits in poor readers could be characterized by phonological awareness differences, by RAN differences, and if you happen to have difficulties in both of those areas, those children would be the most impaired readers. This has been validated across dozens and dozens of participant samples and languages, importantly. And one of the things that Marianne would be, say I was remiss if I didn't point out was that Marianne and Pat Bowers never intended the double deficit hypothesis to fully explain all cases of children with reading difficulties. That the thing that they were doing was pushing past the phonological only deficit view that was prevalent at the time to push us toward thinking about as a field that the complexity of reading must mean that there are multiple deficits that could give rise to reading difficulties. And by at least starting to consider the possibility that there are 2 independent deficits, such that you could have one in isolation or both together as a double deficit, might better explain the landscape of reading difficulties. So really important to think about that. And I am going to quickly check in on the questions for any clarifications. So do you cover up each row as the child test, or do you show them the entire sheet? Similar to reading, we show them the entire array at a time. Children can use their finger to follow along each row if they'd like, but they don't have to. So in that way, it best mirrors general reading. I'm going to save the next question from Kara because it's a bigger picture question till the end, and we'll just do kind of clarifying questions now. For colorblind students, you could have them name objects, or you could have them name colors that are easily discernible. You're absolutely right that we wouldn't want the colorblindness or any kind of sensory difficulties to get in the way of that. And then should children be assessed in their home language? This is a great question. Ideally, you would assess children in the language where they're most comfortable, but there aren't always norms for each of those. So you may need to use non-normed measures or create your own or things like that, but it makes sort of benchmarking and things like that a little bit trickier. So a really good question that we'll try to come back to. Thanks for these great questions so far. So I want to share with you some results from a meta-analysis, essentially a study of studies, because we have lots of opportunities to study relatively small groups of students, but we gain much more power when we have the opportunity to bring together a lot of studies that have been done and essentially kind of compare all of their results as a way of studying a question that we care about. So the royal we, I and graduate student Sean McQueenie, who's in my lab at the time, were interested in what the relation between early RAN and later reading was, and thinking about this in terms of alphanumeric and non-alphanumeric RAN. So for example, there may be 2 studies out there in the field, and one study said that the RAN reading relationship was strong, and it had these characteristics: 55 children, this is totally made up, by the way, 55 children, 6 to 10 years old, they gave the participants a RAN letters task and compared that to a speeded reading task. Another study out there in the world might have had a larger sample size with 122. Children were older, 10 to 16 years, and in a wider range. They gave a RAN letters task, which was the same, but then they related that to a non-word reading task. So meta-analysis lets us essentially combine data from these studies at the study level and draw conclusions across the data that have already been collected in the field, because RAN and reading have been studied so broadly. And so existing in the world, there were at least 2 meta-analyses, one from Swanson and colleagues and one from Araujo and colleagues, about 10 years apart. And interestingly, they found pretty consistent results where they looked at children's RAN ability and their reading ability at the same time point. So measured within, a short time period, the same day or within weeks or months. And so they found that the relationship between RAN and single word reading accuracy was 0.46 and 0.45. So really similar results, which really tells us that across these different studies and the bigger Araujo study combined together 26,000 participants across studies. So much bigger than any of us could do on our own in the lab. And this gives us a really good benchmark for how strong the RAN reading relationship is at any given point. And a correlation of 0.45 or 0.46 is a medium correlation, which is about as good as it gets in our field. Then when we correlate to something more complex that involves other skills like background knowledge and oral language comprehension, and we measure it in passage comprehension, there's still a strong relationship, but it's a little bit weaker in the larger study from Araujo and colleagues. And if we separate out reading accuracy versus reading speed in the Araujo study, you can see that there's a stronger relationship around 0.55 between RAN and reading speed than there is reading accuracy. And so we were curious to look at some of these patterns, not just concurrently, but what early RAN might relate to later reading. So strong consistency here across the single word reading accuracy measures, but a stronger relationship with RAN when we looked at a speeded reading measure. One study, if you'll indulge my nerdiness, if I could take a study to a paper to a desert island with me. This is one of my favorite studies of all time from Chris Schatzschneider at Florida State Scholar Center for Reading Research and others, looking at kindergarten predictors of later reading. And in this smaller study, about 189 children, they found the relationships with RAN to be very similar to what we saw in this broader study, which is the broader meta-analysis, which is encouraging, 0.55, exactly the same. And so we wanted to do a meta-analysis to include this research, but also all of the studies that have been done that we could find in the world to see how early RAN related to later reading ability. So Sean McWaney on the left, who now has his PhD and is a postdoc at McMaster University in Canada, and Sujin Choi, who is a PhD candidate in my lab, they did all of this work. The study is now published, and you can see the DOI down there. You can find it. It's open access. Importantly, I love the idea of open access as a love language. I totally believe in open science. So yes, you can find the study in Reading Research Quarterly, published open access, so that you can refer to it. So overall, across all of the research that we did, looking at either pre-kindergarten or kindergarten measures of RAN and future reading in grades 1 through 4, when students were assessed at multiple time points, we chose grade 2, and most common time for students to get identified with dyslexia. And we found that the overall correlation, when we had overall compared data from a total of over 10,000 children, was 0.4. And then we looked at some kind of distinction. So for example, if we looked at reading accuracy versus efficiency, so just accuracy versus accuracy in time, we saw similar relations. But I think this is because we focused on this early time point where not all students are really automatic in reading efficiently yet. They're essentially still working on accuracy. Similarly, why we saw similar correlations, 0.39 for timed versus untimed measures, reading comprehension versus other measures, but the place where we did see a difference was between non-word reading and real word reading. And so there was a stronger correlation between real word reading and RAN than there was with non-word reading and RAN. And that is likely because non-word reading involves a lot of phonological and decoding components that real word reading doesn't necessarily for pretty proficient readers. So we do see a significantly stronger correlation between real word reading and RAN than we do non-word reading and RAN. Okay, I am looking through the questions in the chat, and I think these are bigger picture questions, so these are all really good ones, but I'm going to save them for going forward. So from our study, we saw that RAN relates to later reading, and across these long-term studies, we also know that phonological awareness, phonemic awareness, I use the terms colloquially relatively interchangeably. Essentially, these measures are important and probably the best two predictors of later reading. And so we know that if we look at a single time point, RAN explains variance in reading ability beyond phonemic awareness, but what about longitudinally? And so we had the opportunity through some very fancy stats that Sean did to control for the effect of phonemic awareness. And once we did that, we still saw a moderate effect size and a significant association between RAN and reading. So essentially, the real base take-home measure here is if you're going to make a screener, make sure that it has phonemic awareness, but don't leave out RAN, because phonemic awareness on its own, things like elision or blending or sound identification, are not going to tell you about RAN, and RAN is going to add significant and important information, and we'll come back to that going forward. There are a couple of other studies existing in the literature that really bear out this pattern that we saw, that both phonemic awareness and RAN are important. So I'll go through these two quickly. A now 20-year-old study from John Kirby and colleagues tracked 4 groups, essentially the double deficit hypothesis groups: good RAN and good PA, no deficit; good RAN but poor PA, poor RAN but good PA, single deficits; and then the double deficit group who had poor RAN and poor PA. Or the double deficit, and we are tracking their grade here on the x-axis and their raw word attack score, so how good they are at phonemic decoding on the y-axis. So note that this is phonemic decoding, and we would guess that PA would have the most strong effect on this, not RAN, because it's an untimed phonemic decoding measure. And so what I'm showing you here, and not kind of revealing the whole story yet, is that already in kindergarten, kids are not that different. You can hear my bird in the background. I have a parrot. She's excited. My husband's probably getting home soon. Forgive me. We're all doing our best in our Zoom world. But by first grade, the group that looks the most different is the first no deficit group. They are already kind of jumping ahead in terms of ability in first grade compared to their peers who have one or more deficits in RAN or PA. And if I show you the whole story here, what bears out over time is that the group who is highest is the group with no deficit. The group who's just below them is the group with good RAN but poor PA. Even though we're charting their phonemic decoding, you are better off being in the group with kind of the long dashes and the triangles here than you are with being the open squares and the shorter dashes, which is the group with poor RAN but good PA. So essentially, good PA is not enough to overcome a RAN deficit, even for a word attack task. And if we look at another totally independent study of a completely different group of kids, we see essentially the same pattern, that you are in trouble if you have a RAN deficit, even when we're measuring your word attack, your single word decoding accuracy. So this is really powerful evidence that RAN is an important predictor of early reading, and kids who are already struggling with RAN in kindergarten are highly likely to continue to struggle with reading as we follow them. Okay, 7:42. I'm going to breeze through some studies that tell us about RAN and the brain, because I love the brain. I'm a developmental cognitive neuroscientist. The coolest thing I've gotten to do in my life is have the opportunity to look in the brain of children and try to help use those measures to understand what's going on so that we can best help everybody. So if we see that there are regions in the brain that are important for RAN, like regions that support language and timing and articulation, if we believe this idea that Marianne and I have proposed, that RAN is a microcosm of the reading system, we should see a lot of overlap between those regions that support RAN and the regions that support reading. And so we're showing you some data here from our colleagues, George Giorgio and his group. And this is 15 college students. So they're not necessarily poor readers. They are not young kids. They are the type of groups that we can easily get into the MRI scanner and do a RAN task and have them stay still. So if we can find it here, we can find it anywhere. We're sort of stacking the deck against ourselves for the chance to see this overlap between RAN and reading. So from this study, we see, if you look at the panel A on the left and panel B in the middle, this is the activation of the brain for participants naming a grid of RAN letters, and they're naming them out loud in the MRI scanner. And you see letters on the left and digits in the center. And if you kind of squint your eyes, they are really similar, the parts of the brain that are supporting RAN letters and RAN digits. And now, if you look at the same regions and the same participants that were active when participants were doing rapid word reading, there is again a lot of overlap between the regions that are active when we're doing a RAN task and when we're doing a reading task. And so this tells us that the parts of the brain that are supporting RAN are also supporting reading, and gives credence to this idea we've developed that the reason why RAN and reading are so related is because they tap or recruit so many of the same underlying processes, which we see not just behaviorally, but in terms of the brain here. And other studies since this point have bore that out as well. Another study that I worked on that I'm really proud of from now, oh my gosh, 10 years ago, where does time go? We looked at a group of 90 children who were school age and characterized them based on whether they were typical in their RAN phonological awareness or whether they were below the 25th percentile, characterized as a deficit. And importantly, these groups differed in their reading skill, but not their age or IQ, which might be other explanatory factors that kind of helped us understand our results. So we had representative groups who were either control, meaning neither deficit, phonological deficit only, double deficit in PA or RAN, and RAN deficit only. And we gave them a visual word rhyming task, because in the scanner, it's hard to play sounds. If you've ever had an MRI, it's super loud. So we put up on the screen in the MRI scanner for these school age, very cooperative kids, things like bait and gate, and ask the kids to press a button whether the words rhymed or not. So they're already doing a reading and phonological task. And what we're trying to figure out is whether that differs by these different groups of plus or minus RAN ability and plus or minus reading ability, phonological awareness ability, excuse me. So what we found is that there were two essentially gradients in the brain. The phonological awareness gradient, the kids who had no deficit versus a single deficit in phonological awareness versus both deficits in phonological awareness and RAN, were less active in their brains in these two regions outlined in red, in the left inferior frontal gyrus and the left sort of temporal parietal region. You can characterize this as angular gyrus, probably best after that. And then interestingly, with the RAN gradient, the kids who had the weakest RAN ability showed differences in activation in the right cerebellum, which we know is associated with timing. And if I sort of graph these out for you, the students who are controls activated these regions when doing the reading task. The kids who had a single deficit in RAN or phonological awareness showed a sort of medium but decreased level of activation. And the kids with a double deficit were actually deactivating this area, meaning they were using some totally other part of the brain to do this task when we're asking them to read words and decide if they rhymed. I'm going to skip this phonological and RAN gradient connectivity differences because it kind of shows the same pattern, that there are meaningful distinctions between kids who have a RAN deficit profile from a phonological deficit profile, which I think is the main take home here. Essentially, it's not the same. You have a differently built brain if you're having trouble with RAN versus phonological awareness. So to wrap up the research from this so that we can get to some questions and I can give you some more insights. RAN seems really simple, just that grid of letters that I showed you, but it is truly an elegant task in its ability to robustly relate to later reading. And we think that it does this because of the number of shared processes that RAN and reading tap in the brain. And RAN is indeed a deficit in dyslexia, which we've seen from what I would characterize as a zillion studies, and that children with a RAN deficit have distinct brain profiles, and that means that they need distinct intervention and support from kids that have phonemic awareness deficits. So what do you do if you are a teacher or a parent or a clinician or a practitioner or a policymaker, which I imagine characterizes most of you all? What should you do with this? So one of the things I hope that you can appreciate is that this tells us that we need to switch from a traditional kind of categorical light switch view of dyslexia. You either have it or you don't, and we can measure this and we can figure it out, to what I like to think of as a more modern science-informed view of dyslexia that's more like a soundboard. And if you've ever seen someone operate one of these boards in a recording studio, you'll see that sometimes when you slide one set of sliders, they might independently move another set of sliders. So for example, if you slide the slider for language comprehension ability and that goes down, it might negatively also affect ability to develop background knowledge, which is going to impact passage comprehension and so on. So we see reading now as this very multi-componential process that requires all of these different things, and they're all each on a continuum and can vary independently in some ways, but are linked in other ways. And there are all of these risk and protective factors early in development that can help shape a child's reading ability. What are we missing? What's lacking? What am I trying to do in my research? The big thing that I'm asked often is, what do we do now if I have a child who has this RAN score? How do we proceed? So this sort of a formula, or what I would call a calculator approach, which we have been working on for mental health and neurodevelopment and other domains, but are still struggling with really kind of trying to sort this out in reading. If I know a given child's scores on all of the measures we would want to measure at age 5, I still can't be sure, and I don't think anyone can honestly claim to know exactly what their reading ability is going to be. Doesn't mean that we can't identify children at high risk early so that they can get early intervention when their brains are most plastic and when it's most helpful. Early intervention never hurt anybody, but being able to target this better would allow us to deploy our resources as effectively as we can. So how do we use RAN as a screener? Because we can assess RAN starting around age 4. Before that, kids have a hard time sort of doing the left to right and being accurate enough that their naming is automatic. So around age 4 is when we can start doing this. We can absolutely include this in kindergarten screening, and the evidence is there that we really should. So if in your district, RAN is not included in your kindergarten screening battery, send me an email, let me share you these slides, and let's get that included, because it gives us so much more extra information beyond letter knowledge, family history, phonemic awareness, all of these other things that we might be measuring. A question that I'm asked all the time and that is hard to answer is, what does it mean to have a low RAN? So where is the cutoff of what is worrisome level of RAN ability compared to peers? And just like reading or social cognition or anything else, these are continuous measures, and there's not one score that necessarily means that you have a deficit. It's all kind of where we draw the line on the continuous ability. And so we need to kind of think about this in the constellation of the child's other abilities to decide what is going to be something that's a worrisome score that means that we need to monitor, we need to provide additional intervention, things like that. And importantly, what does a low RAN score mean? So if you've got a kiddo in kindergarten who scores in the 15th percentile for RAN, what does that tell us? Unfortunately, reading is so complex. RAN is almost equally as complex. That I really like this analogy of RAN is like a check engine light. And from this beautiful figure from Wolf-Bowers and Bibble, they are showing all of the many and also often bidirectional and kind of complex relations that go into being able to do RAN. And so what RAN tells you is that one or more of these important processes that are also going to influence reading is not working well. It doesn't tell you which one, and it doesn't tell you or which ones and why. So if you think of RAN as like the check engine light in your car, it means you need to go and get more information. You need kind of a further diagnostic. And so sometimes that further diagnostic can make everything clear, and sometimes it can't. But just having low RAN in itself doesn't tell you necessarily what's going on underneath the hood, if you'll let me continue the car analogy. So what do you do if you have a child or a student that you work with who has low RAN? I'll tell you one thing that we shouldn't do, and that is try to fix their RAN, because there's almost no evidence that that works. I'm going to show you some data from one, kind of one of the studies that did the best job in trying to do this, and tell you why I don't think that it's good evidence-based practice for what we should do for students who have low RAN. So this study had 18 children who had dyslexia, and they practiced RAN a lot over a few weeks. And then they had 13 typical readers who didn't do any kind of intervention. And after doing the same RAN grid over and over and over and over, on average, the biggest RAN time improvement that the trained dyslexic students had was less than 0.4 seconds to complete the whole grid. So it's really not a meaningful amount of difference in their abilities. But what they did in this study was try to relate that to how much a reading ability changed before and after training, and actually how their brains changed before and after training. So they spent a lot of time and effort to do this. But I think this is a good example of, I'm going to really disagree with their conclusions where they say training RAN makes reading better and changes the brain. I don't think that's what we see. So these were kids 8 to 12. They got 12 hours of direct intervention and RAN practice over 2 months, and 18 versus 13 kids. And the authors say that the results showed significant improvements in the trained children in RAN performance and in word reading accuracy. But if we dig in, as I want to do as a researcher, let's look quickly at this graph from their research. So what we're looking at on the x-axis is testing time. So time 1 before training and time 2 after training, or after no training if you are the typically developing kids. And on the y-axis here, we have the composite score. They had them do a couple of different RAN measures in seconds. And so what they found was that across these pooled RAN measures and children, on average, the kids with dyslexia got a little bit faster in the RAN naming. And interestingly, the typically developing kids got a little bit slower. Their time went up a little bit. But at the time too, there was not a significant difference between typically developing kids and the kids with dyslexia on RAN. So you might say like, oh, we've fixed their RAN. We've gotten the dyslexic kids into the same range as the typically developing kids. But if we separate this out by how this relates to their reading ability, on the left, we are plotting their word reading accuracy on the y-axis, and the typically developing kids basically stayed flat because it's hard to get much more accurate over 12 weeks on a standardized reading task without any training. So that's kind of a good sanity check. The kids with dyslexia got a little bit better. But if we look over here on the right at the word reading speed, the kids with dyslexia got a tiny bit faster, but without any training, the typically developing kids got a lot faster. So their slope is negative and low from time 1 to time 2. And so when we test this when the authors test this as an interaction, they find a significant group by speed interaction, but this isn't really meaningful because when we just look at the dyslexic kids and test just whether their time 1 versus time 2 is different, it's not significantly different. So essentially this is what I would chalk up to a retest effect. They got this chance to take the test again, and when you take the same test again, you on average do better. And then when they did brain scans of these kids and took tons of money to do this, what the authors are plotting on the x-axis here is RAN change on average per grid in seconds. And this really gives us a nice window because I've drawn circles on here to show the two kids over here in blue actually got slower in RAN over time. Their RAN time went up with lots of practice. And then the next five kids here in red, barely changed. Their RAN time was no less than 0.1 seconds difference. So there was a correlation between changes in a part of their brain that we know is important for reading, but the RAN differences were so infinitesimal, and this was such a small sample, it really doesn't tell us anything meaningful. So even though the authors say that this results in better RAN reading accuracy, there were actually no significant differences in word reading accuracy in the group who got RAN training. This was a small sample. There was no comparison group of dyslexic students who didn't get any training or got a comparison training. So this could be a placebo, like, oh, you're going to be better at this, ready to try it again. Here you go. I believe in you now. Something like that. I'm not saying that the authors did that, but it can happen. And just maturation. Just the kids were 3 months older and better at the task. And this is kind of the same pattern for all of the studies out there that tried to train RAN itself. The data are not there to say that this is the way we should go. So take-home message is don't train RAN itself, just like if you want to hear my diatribe on repeated reading, I'm glad to share that. The best evidence-based practice is to train the skills that an individual child has difficulty with and build their accuracy and then their automaticity and efficiency. So if you've got a student with low RAN, keep an eye on them, because especially if you've identified their RAN difficulty early, they are very likely to have intact single word, especially sight word reading accuracy, and may have good decoding, maybe a little bit slow. But when they get to the stage where they are expected to be reading fast and efficiently and with automaticity, that's where the RAN difficulty is really going to manifest. And so it might not be until second, third grade or later that a child who has RAN difficulties is really starting to fall behind their peers if their other phonemic awareness and decoding abilities are intact. So you can do your best to bolster those other skills, build PA, build vocabulary, language comprehension, all of those other pieces in the reading rope, and try to develop automaticity through varied and authentic literacy activities like reading, I don't want to say decodable texts because so many of them are terrible, but reading developmentally appropriate texts, let's say that. And so to wrap up, what I hope you got to hear tonight was that RAN is a powerful screening measure that presages later reading difficulties. It acts as a check engine light that shows you that something in the underlying processes that support reading is not as optimized as it could be, and that effective remediation for students with RAN difficulties should focus on their broad profile of reading and language abilities. And then I got a moment to plug, since the Reading League is great and I don't want to take any of their money. I'm going to take 1 minute of your time and say, I'm part of a super cool study where we at Northwestern are one of 27 sites around the country that is starting a study to follow babies from before they're born in the second trimester of pregnancy until they're 10 years old, and look at again, a zillion different developmental outcomes, their behavior, their mental health, their cognition, all of these kinds of things. But of course, I'm really interested in their language and reading ability. And it's so rare that we get the opportunity to look at the very earliest origins of this starting before birth. So if you know someone who is in the Chicago area or somewhere else around the country, because we have these 27 different sites, and might want to enroll in this really cool groundbreaking study funded by NIH that's going to let us follow 7,500 children from before they're born until age 10. It's called the Healthy Brain and Child Development Study. This is our Northwestern address, or you can Google it and find other sites all around the country. We're going to start enrolling actual study participants in July, but up until then, we are doing lots of practice and making sure that our team can do all of these brain and behavior measures really well. So if you have a tiny human in your life and you would like to learn more about their brain and their behavior, let me know. Here's our study email. Thanks for indulging me on that. And then let's get to your many questions that you have here. And then here's all my contact info if we don't have time to answer all of the questions for tonight. Okay. Q&A. The bird's excited about this.
So yeah, if you have time, I did put, just real quick for those who have to leave, I did put in the chat the link for the CEUs and the PD hours, and then also another link for our membership if you would like to become a member. So you did get quite a few questions in here.
Yeah, this is my favorite part.
Do you want to read them? Do you want me to read them? It's up to you.
I'll go for it.
Okay.
Okay, so for early on, Kara asks, some have commented now that phonic-based instruction is happening at school. Children are actually not familiar with letter names and so are sometimes getting confused and saying the sounds in rapid letter naming. What would you say about that? Some have said that they don't think the CTOP has been an accurate measure for a few children that they've assessed because of it. What would you say to this? Great question. I think we can't compare for a standardized and normed measure like the CTOP, rapid naming subtest. If a child is saying letter sounds rather than letter names, that's not the task that we're asking them to do here. So you could look kind of qualitatively about how they're doing and kind of get an idea, but I don't think it's something valid to get a percentile and kind of use that as their RAN ability. And it's actually meaningful, right? If a child, we want kids to know flexibly letter names and letter sounds interchangeably. And if they're not able to do letter names automatically, then it would be more valid. I'd rather know their ability to name accurately an objects or colors array. So I think I would lean toward that until kids can really distinctly know their letter names and know the distinction between letter names and letter sounds. So I hope that answered your question. Put another question in the chat if I didn't get that, Kara. Okay, next, how do you account for children that have expressive deficits? So this is such a good question, and it comes up a lot, especially with kids with word finding deficits or sort of retrieval deficits. It plays in it, and it's part of kind of the thing of like the check engine light is we don't always know exactly what the underlying deficit is, but it tells us that there's something meaningful going on that is going to make reading more difficult. So if you have a child who you already know that they have expressive deficits, you can still give them a RAN task as long as you know that they do accurately know the names of the items to be named in the task. And you can kind of triangulate that as a piece of information in your toolkit to sort of know what their profile is and what their underlying difficulties are. But I don't think it changes kind of the broader picture. I think RAN difficulty in a way is an expressive difficulty, kind of a Venn diagram overlapping category. Okay. Next, how do you explain students that perform better on alphanumeric RAN than color and shapes, where color and shape are significantly slower and then significant impaired range versus low average for alphanumeric? Really good question. So as we become proficient namers, we are all faster for alphanumeric than we are for non-alphanumeric stimuli. But usually a given person's profile is relatively similar in like their standard scores across those items. So if you have a child where color and shape are much lower and alphanumeric is higher, it's a little perplexing, right? It's not a profile we would expect if their just alphanumeric wasn't as familiar or accurate. And so I think, to be honest, the first thing I would do is retest on another day. And because there are no practice effects in RAN, really just make sure that that is the profile. And if it is the case, then I would be curious about kind of a broader neuropsych or psychoed evaluation to understand if there's sort of a broader naming deficit that maybe is affecting objects and colors more so than alphanumeric, because it's more common to see the opposite, that object and color naming is relatively intact and alphanumeric naming is relatively proportionately lower standard scores. So it's a good question. And I think I would just kind of want to have a broader idea of the profile to go from there. I'm trying to speed through these questions, so forgive me. Can you talk about which dyslexia screeners include RAN assessment? Great question, and you're testing my memory. Many of them do. So there are many, I can talk about the test batteries that include it off the top of my head. So the CTOP, the WRMT3, the SELF 4, but not the SELF 5, paradoxically, are the three that jump to mind. And I know that there are others. And across the dyslexia screeners, there's a variety. So for example, some of the tablet-based ones, like Early Bird Literacy, which is led by my colleague Nadine Daub, does include it. I think you can look at your individual screener and make sure it's there. But I don't want to keep speculating because my memory is not as good as your ability to just double check your screener and make sure it's there or that it's included from a different battery. Okay, if a student can read well, has fast processing, but does not comprehend and hold on to what they read, is this more of a language-based issue? I think this is where like a deep dive psychoed neuropsych assessment is needed to kind of try to triangulate and pinpoint that ability. So it could be that RAN and sort of retrieval of symbolic information could be the level at which they're having difficulty, but a good comprehensive assessment is going to give you the best information there. Next, if a student achieves scores on RAN within the below average range, how mutable or responsive to intervention is RAN? I hope I addressed that in our talk. It really seems like training RAN itself is not the way to go. RAN seems like a pretty inherent characteristic, just like we would think of sort of processing speed or cognitive ability. It sort of tells us something about the way that our brains are built. And so the best evidence base tells us to strengthen all of the areas around it rather than to try to remediate RAN itself. I think this is a question about the brain figures I showed. Are these regions of the brain that support language? Yes. So the regions that support RAN are the regions that support expressive and receptive language. Indeed, it's a good sanity check, right? If we had gotten like the olfactory cortex that supports our smell ability, and that's what lit up when we tried to do a RAN test, that would tell us that the researchers are doing something really wrong, but that's not what we saw. So good question. Can you have a RAN deficit, but a good fluency reading and be assessed as a top reader in DIBELS and IDEPEL? Potentially early on, yes, but as demands increase and as everyone in the classroom is expected to be a faster and a more automatic reader, it's unlikely that if you had real difficulties with one of those tasks that underlie RAN would sort of let you be a reader who was really automatic and fluent on a speeded task like that. So it may be kind of a quirk. It may be that, kiddo had a sneezing fit in the middle of RAN, which happens sometimes, or things like that, or that early on they're accurate enough that they can kind of keep up with their peers, but it's likely that over time that gap is going to grow. And that's where monitoring can be really effective. Okay, what does intervention look like for a child with RAN deficit, and how is it different from the PA deficit? So if you have a child who has both RAN and PA deficits, we know that there are strong, high quality, evidence-based, structured, multisensory explicit programs to support PA. And that's where I would put my time and money, because we don't have anything that fixes, quote unquote, RAN itself. If you can build up a student's PA ability, that's where I would focus, but keep the effects of the RAN deficit in mind. So they're going to probably struggle for a longer time to build from automaticity to efficiency, accuracy to efficiency to automaticity, and so on. But because we don't have a good way to address the underlying RAN deficit, I'd focus on the things that we know that we can work on, like the PA deficit, and keep that in mind. Okay, I'm going to keep going even though we're over time, and might as well get to all of these questions and folks can watch on the recording. Next, are RAN assessments helpful when evaluating adolescent struggling readers? I really think so, yes. So especially if you have a struggling reader and you're really not clear on what is causing them to struggle with reading. I was a high school teacher for students with language-based learning disabilities. It can be really illuminating. And I think for older readers who can also understand these kinds of things and talk about things like neuroplasticity and neurodiversity and things like that, understanding not only for what their profile is and how you're going to support them, but helping them understand themselves as a learner can be really powerful. So yes, these RAN tasks that exist are normed up through the teen years, through 18 and sometimes beyond. And so I think it's a great thing to get a really full picture of the student's reading ability. And also, if RAN is something they struggle with, like explaining what that is to them and why they may have difficulties with some particular aspects of reading. I think that can be really powerful. Okay, what is a good RAN assessment? We have used map fluency for a dyslexia check, but I noticed that on the RAN section, it can never get a good result because the computer didn't understand the child. Yeah, this is a limitation, I think, of technology that I think will be, I imagine, getting better over the next few years. When you have to use the speech recognition and the child has to kind of perfectly follow the grid and not miss an item or repeat an item or things like that. That's where one-on-one assessment of RAN is really pretty quick. It takes less than a minute to do a given RAN task. And I know all of us are stretched and we don't have all of the resources that we wish we had. But if you're gonna choose a task to have a human identify, administer, I think this is a great one. It's quick. Kids like it. It's easy. And I agree, the automated programs out there don't necessarily do a great job at scoring them accurately. So I like a good human administered RAN task. Okay, someone says, I'd like to hear about repeated reading. I'm going to put that on hold for a second and get to these other questions because I could talk about repeated reading for a long time. How often should you test RAN and in what grades? Good question. So I think in kindergarten screening, when you're doing your other literacy screening measures, we generally see that a good measure of RAN, so not one where a computer is trying to guess at what a kid is saying or something, but a well-administered RAN test, kids don't move a lot in their relative standing compared to their peers. So if you come out in the 70th percentile in kindergarten, it's extremely unlikely that you're going to be in the 10th percentile the next year or things like that. So I would say that if you've got to put your time and effort somewhere, I would put it into kindergarten screening with RAN, and you can repeat it as part of sort of your literacy monitoring. I wouldn't say that it's necessary to do more than once a year, honestly. Use your resources as effectively as you can. And kids should stay pretty stable for the most part when you have a good administration. Okay, next question. In Kilpatrick's 2017 book, great book, he mentioned studies or research that show that while we cannot impact RAN directly, learning to read can impact RAN. Is Norton aware of teacher-friendly research about this, or what is her opinion based on her professional experience? So yes, learning to read changes our brain in so many important ways, and it is the case that as you learn to read, your RAN becomes faster, and so kids who are better readers, where RAN was already correlated with reading, their RAN speed, when we kind of stopwatch it, gets faster. But generally, like I said, kids kind of remain in the relative standing compared to their peers. So it doesn't mean that we have a way to train RAN. It kind of means that we're getting kids, especially with alphanumeric RAN, more familiar with these symbols, and they're just getting more and more automatic as they become more proficient readers. And so indeed, their actual time to complete the RAN task is getting faster, but for the most part, because of that and the RAN's relationship with reading, kids are maintaining their relative standing compared to their peers. Okay. Does the student need to show automaticity to prove mastery? In Wilson, students need to reach a level of automaticity before moving on to the next step. And is accuracy sufficient for a student with low RAN? I had a parent reach out to me with this exact question, and I think it's a really good one. I've been thinking about it a lot. I think ideally we want to build accuracy and automaticity for all students. And I think when you are in this case where you know you have a student who's going to have trouble building automaticity, even if they can be accurate, it's a tricky trade-off. And I think that's where having a super experienced, strong teacher, reading specialist, professional makes all the difference, because they can help knowing that student and knowing their profile kind of find the right balance for where to push and where to sort of stick to the fundamentals and build. I don't think, to be honest, we have great research evidence about what to do in that case. And so I'm gonna kind of like punt that a little bit and say, I think there's probably a happy medium to be found, and it may differ also to like helping the student, you know, go on to read more interesting texts, even if they're slow but accurate, versus kind of doing the same type of texts over and over. And I think that's where just having a really great person working with your students on your side, if you're lucky enough to do so, is going to be your best bet. But I don't think we have strong research evidence about what to do in that case. Where can we access the RAN assessment? So lots of those measures that I mentioned exist in the world. There are also some state created measures. So Illinois doesn't have one, but some of the other states have created their own RAN measures and normed them. So you can, even if you, worst case scenario, you can put a bunch of familiar colors or letters in a grid like that, and just qualitatively, you know, you won't be able to compare a student to their peers and get a normed score, but just seeing if they can move pretty fluently, easily across the grid. They don't kind of, one of the things that amazed me after doing this with research studies with, again, a million zillion students, is that some students are like a metronome, and they just go right through and they name everything. And they're like, why did you make me do that? That was so easy. And other students start off really strong and they're like, A, S, O, D, P, D, A. And by the end, they're like, A, P. And it's like they had never seen a letter before. And so that really tells you something. Even if you can't compare their time to their peers, you can kind of qualitatively see how difficult it is for them, and that there's some sort of like little, I picture like a little like marble bottleneck, or like the Kennedy Expressway in their little brains, and they're just like reaching this bottleneck where they're really having trouble. So lots of measures out there, and drop me an email if you want info on specific measures. Does RAN improve with age? So everyone up to a certain point, and maybe middle schoolish, kind of gets faster as we just get more automatic and our cognitive abilities improve. And does reading automaticity improve with repetition and time? Reading automaticity improves with automaticity of underlying skills, but not necessarily with RAN practice, I would say. Besides the CTOP, is there another test for RAN assessment? RAN-RAS tests, WRMT, and I know, I think it's that one of the Kaufman batteries also includes it, but send me an email and I will do the deep dive and pull out my actual notes on this and send it to you. Best RAN screeners, anything that's a normed RAN screener that is a person administered rather than AI machine learning administered version. Does RAN predict developmental language disorder? Great question, Louise. So developmental language disorder is defined by difficulties with expressive and receptive language. It's usually not defined on the basis of automaticity. So I think there is a high overlap between kids with DLD, and kids with RAN difficulties. And so a student who has DLD and RAN difficulties is also likely to have reading difficulties, but it's not diagnostic. It's not part of the criteria for DLD. And interestingly, kind of the kids who are going to have more trouble with sort of the word finding and expressive vocabulary aspects of DLD are likely to be the ones who also have difficulty with RAN, as you may suspect. So it's not diagnostic, and when a child's being assessed for DLD, RAN is not usually used. It's usually only used for literacy, hopefully, if at all, but a really good question. Next, does increasing decoding skills increase RAN? So yes, in the way that just building that automaticity of sound and meaning associations, and we talked about from Dr. Kilpatrick's book, yes, those things do sort of reciprocally grow over time, but again, it's all kind of relative to peers. And so generally gaining in a program like, for example, OG or Wilson in your decoding skills is not necessarily going to make your RAN faster standard score wise compared to your peers. Okay, another question about repeated reading. I'll save that for a minute. If phonological awareness can be taught and RAN cannot, then why did the kids with the phonological deficit do worse than the kids with the RAN deficit? Great question. I share the same curiosity. We don't know what, if any, intervention the kids with a PA deficit in the studies that I showed were getting, but you would expect in a perfect world where they are identified with phonological difficulties and we're getting high quality structured multisensory phonemic awareness intervention, that they would get better and wouldn't be so poorly off, but that we don't know what happened in those studies. Okay. Does building orthographic mapping skills further support RAN levels? It may, likely would, but I don't know of any evidence, any studies that have looked at that directly. So it's a good question. I think anytime we're building that automaticity of sort of sound to language and things like that, it's probably, or sound to symbol, at least for alphanumeric RAN, it's probably building those things, but I'm trying to think. I can't think of any research off the top of my head, but if you really want to do the deep dive, I was an outside thesis examiner on a thesis that looked at orthographic competence in RAN. So drop me an email and I can go and refresh myself on that. It happened pre-COVID, which seems like 7 lifetimes ago. So let me know. Okay. Would you expect a neuropsych report to include RAN? Would I expect? Yes, I would. Does it always? No. It's an easy, I realize this is like a big advocacy thing and not everybody knows what to ask for, and any parent or teacher or professional, everybody's doing their best and doesn't, not everybody is kind of has this all in their arsenal. But if you're sending a student for a neuropsych and you're concerned about literacy, you could ask if they're going to assess RAN, and if they're not, they absolutely should. And if they say it doesn't matter, I might say you should find another neuropsych assessor, but that's just me. So again, send me an email if you need me to write a much more strongly worded response. Okay, follow up, would DLD and low RAN be high risk for double deficit dyslexia if there are significant indicators of dyslexia? Really good question. So I think there's a strong Venn diagram between DLD. This is me drawing my Venn diagram in my hands. Between dyslexia and DLD, well, reading problems and DLD, because if you have trouble with the fundamental components of language, by definition, you're going to have trouble when you bring that to written language from spoken language. Not all kids with DLD have phonological deficits per se, so it's not 100%, but all of these things tend to co-occur more often than not. So I think if you've got a kid with DLD, get them a good assessment for literacy, even preemptively, if it's possible, to kind of know what the future may hold. But I don't think it's necessarily always the case that a student who has DLD will necessarily be sort of a double deficit category student. All right, 4 more. We're cranking through, y'all. Okay, for students above first grade, we are pushed to use CBM measures to progress monitor. If student has difficulty with RAN, should we be using CBM, or will this not show accurate reading growth for the student? Good question. So if you have a student who has difficulty with RAN, if they are making kind of age-appropriate gains in phonemic awareness, decoding, sight words, things like that, they could still show growth. It's not that they're going to be stagnant. I think that the thing that might not fully be eliminated is if they are not making gains, especially in speeded measures, and especially as they get older, they're likely to start kind of showing a widening gap and kind of being lower compared to their peers in reading, because the RAN deficit is going to kind of manifest more obviously when they're asked to be a more automatic and efficient reader. So progress monitoring is good in general, and we should do it. I think you're bringing such a good point that we need to consider not just the progress monitoring measures, but kind of the bigger picture. And so if you already know that a student is low in RAN and you're just doing an accuracy-based progress monitoring, they might look fine, but it's not telling you the whole story. So I hope that that answers your question. And yes, do progress monitoring, but keep in mind the forest and not just the tree of their score on the progress monitoring. Okay, if you're testing kiddos in their home language, if testing kids in their home language is not an option, would you still recommend administering RAN? What results would you be looking for? Such a good question, because we have so many students whose first language is not English. I don't know of any off the top of my head measures that include norms in other languages, even Spanish. So I think then, if you know that the student can be accurate and pretty automatic in naming in English, then you can administer in English and kind of keep that in mind relative to their broader English language ability. And if English is not the language where they're most proficient and they're not automatic, you could have them name the items in their home language, and again, kind of take that qualitative approach. Like, are they just moving through the grid and they're speeding through and they seem like this is really easy for them, versus are they really struggling? Are they making errors? Are they getting hung up? And you can kind of use that as more of a qualitative observation. So that's my best advice. And we need to do better as a field for having norms in other languages. I have, Louise gave a kind reminder to give a shout out to Blame It on Gutenberg, which is a documentary that is freely available online. If you Google Blame It on Gutenberg, that when I was younger and skinnier pre-COVID that I was in, and I was really nervous, and so I blinked my eyes a lot, but I think I said relatively smart things. So if you want to learn about that, the idea, Blame It on Gutenberg, is that dyslexia wouldn't have existed unless Gutenberg had invented the printing press. So it's great research from some very smart researchers in the field, and also follows the stories of a couple of families who are seeking accommodations and support for their children. So great, because it's freely available. Just Google Blame It on Gutenberg. And then I will give my last, actually, can we stop recording and I'll give my thoughts on repeated reading? So thank you, everybody. Really appreciate you being here. And now we'll talk about repeated reading.